For this video, we'll be focusing on the amplitude and how to recognize what the amplitude is and solve for it. So if we have just and we'll just base all this off of the sine equation. The cosine equation would act exactly the same, of course, starting at a different point on the y-axis, but still identifying the amplitude and then again the period the same way. So if we look at this, we see y equals sine of x. Well, what we basically have here is we have y equals a times the sine of bx. And so in this particular case, y equals the sine of x is actually the a and the b are understood in this case. And so what we would always understand something to be if it's not there is actually a given 1. So in this case, we're only dealing with the amplitude, and so that's the a value that's written in front of the sine. So we can see here that we have an understood 1, so the amplitude of the graph is going to be 1. And so at this point, what you know is that the graph will never get higher than 1 and never get lower than -1, and that amplitude is the result of that height from the x-axis to the highest point, the maximum value. And so basically, since amplitude is representing a height or an actual length, it's actually going to be represented by the absolute value of the a. And what happens here is that if we gave you a negative a value, that would basically reflect the graph or flip it across the x-axis, but the amplitude would still be the representation of its height. So whatever a value we have, we're going to actually take the absolute value of it to represent the amplitude. Now you can see in the second part what happens to the graph when we actually have an amplitude a little higher. So you can see the 3, and it basically starts making these waves go much higher and lower, and gives you a much bigger graph per se. Notice that the cycle in this case, the period from 0 to 2 pi, one cycle did not change in length with the amplitude. So the quickest and easiest way to determine amplitude and how big that graph's going to be is by simply looking at the a value in front of the sine curve, in front of the sine part of the graph, so or equation, excuse me. So for sample problem number 2, we've given you a cosine graph. So you need to remember the basic properties of a cosine graph. Then you need to remember what the amplitude, how the amplitude is going to affect that graph. So go ahead and try sample problem number 2 at this point in time. Okay, so we recognize here that the amplitude is 1/2. So that tells me the highest I'm going to go up on the graph is 1/2, and the lowest is going to be -1/2. So with the cosine, I would normally start at 0, 1, but since my amplitude is only half of that, I'm actually going to start that process at 1/2. Then we know that as we go through this process, what it's going to look like from a standpoint of a curve, it's actually going to go like this. And then of course I need to do the other side of this, making sure that I don't go above 1/2. And of course we would just graph as much of the x-axis as we have available to us, and to show the continuous cosine curve. And so that's what your cosine graph would look like with an amplitude of 1/2. Alright, next video we'll talk about period.